Okay, we're looking at Minitest week 31 and question 2. Okay, so we've got a non-uniform rod. So you need to read the question really carefully because it's easily missed whether they say it's a uniform rod or non-uniform. So if it was a uniform rod, the centre of mass would be halfway along the rod. If it's not uniform, sometimes they ask you to find where it is. Here they've told us. So the centre of mass of rod is 6.2 metres from A. So let's sketch that out. So I've got the supports at either end and the centre of mass is just a bit, so it's over halfway along from A, and the weight of the rod, they give me the weight rather than the mass, is 4 newtons. So there's going to be a reaction at A and a reaction at B, and they're not adding any extra weights on, so they're the only forces acting on that, the weights acting on that. And I need the reactions on each of the two supports. Now, to be honest, it doesn't really matter which I find first. Seeing as they've given me the distance from A, so they've told me that that's 6.2 metres, I'm going to take moments about A, but it would be just as straightforward to take moments about B. So if I'm taking moments about A, I need the distances of those two forces from A. If I'm taking moments about A, then I don't need to worry about the reaction at A. So I know the whole rod is 10 metres long. Okay, so I'm going to take moments about A. So I've got this force pulling down, so it's as though I've got a pivot at A and that force is pulling down. So if it's pulling down on the right-hand side, it's going to be trying to turn the rod clockwise. So that clockwise moment is going to be a force of 4 newtons times a distance of 6.2 metres. And then I've got this force pulling up. So if it's pulling up on the right-hand side, that's going to be trying to turn it anti-clockwise. And that's going to be a force of the reaction, a moment of the reaction at B, which is what I'm trying to find, times the distance from A, which is 10 metres. So that's going straight into my calculator because I'm lazy. So 4 times 6.2 is 24.8, and that's in Newton meters. It's just part of our working, so it wouldn't really matter if I didn't put Newton meters, but that would be the units for moments, and that is 10 meters times RB. So RB is going to be 24.8 divided by 10. Okay, so if you took, so the alternative would have been to take moments about B. That would have been absolutely fine. Yeah, as long as you can say that that distance is 3.8 meters, you could just as easily have taken moments about B. And then you would have found the reaction at A to start with. Whichever you find first, though, you don't then need to take moments again. So we do need the reaction at A, but it's going to be way, way easier once you've got one of those forces to resolve the forces vertically. So the total upward forces are the reaction at A and the reaction at B. So the reaction at A plus the reaction at B, and the only downward force is the 4 newtons down. So together they must add up to 4 newtons. So the way I've done it, I found the reaction at B first. So now I can find the reaction at A. If you found the reaction at A first, that's fine. Hopefully you got 1.52, yes. So you would have got that. If you took moments about B, you would have got that. And then you could have done 4, take away that to get the 2.4 Newton reaction at B. And that's us done.